How were aqueducts different from other water sources? Have you ever wondered how ancient Rome managed to supply its vast population with fresh water? The answer lies in the remarkable engineering of aqueducts, which set them apart from other water sources of the time. While many ancient cities relied on wells, rainwater collection, or nearby rivers, these methods had their limitations. Accessing water from these sources often required significant manual labor and was heavily influenced by geography and seasonal changes. In contrast, Roman aqueducts were a game changer. They transported large volumes of fresh water directly into cities from distant springs, using gravity to move water through carefully designed channels. This was not just about convenience, it was about scale and reliability. Aqueducts could continuously supply entire cities, meeting the needs for drinking water, public baths, latrines, fountains, and even some private homes. The water primarily came from underground springs, chosen for their purity and steady flow. It was transported through conduits made of stone, brick, or concrete, often buried underground to protect it and maintain a consistent temperature. This system allowed Rome to grow far beyond what local wells or rivers could support. Aqueducts also featured sedimentation tanks to remove debris and distribution tanks, known as castella aquae, to regulate the flow of water to different parts of the city. Public fountains were prioritized, ensuring that even the poorest citizens had access to clean water. Excess water was used for industries, gardens, and even helped flush the city's sewers. This level of organization was unmatched by other ancient water sources. Engineering these aqueducts required precise surveying to maintain a gentle, consistent slope. This slope was crucial for water to flow by gravity without causing erosion or damage to the channels. When valleys or lowlands interrupted the route, the Romans built bridges or used pressurized pipes to carry water across. These techniques allowed aqueducts to traverse long distances and varied terrain, something simple wells or local streams could not achieve. Compared to other water sources, aqueducts significantly reduced the daily burden of water collection. They supported urban hygiene and enabled the growth of industries that depended on large water supplies, such as milling and dyeing. They also helped manage public health by separating clean drinking water from wastewater. However, concerns about lead pipes, which were used in some aqueduct systems, would later arise. From the Roman perspective, aqueducts were not just functional, they were a symbol of civic pride and engineering skill. They showcased Rome's ability to control nature for the benefit of its citizens and were protected by law. While other cities might have impressive wells or cisterns, none matched the scale, sophistication, or impact of Rome's aqueduct network. This system set a standard for urban water supply that would not be equaled in Europe for centuries.